Good morning, learners. In today's video, we are going to understand the practical problems on union and intersection of sets. As you know, we have covered in the previous video the operations on sets. Under the operations, we have understood what are the union and what are the intersection of sets. Okay, so let us start for today's topic. And to start this topic, we will start today with the help of a Venn diagram. That it is the Venn diagram. This rectangular denotes the universal. It denotes the set A, and this is another set. This is set A. This is set B. So if we see, this is A minus B. A minus B. Which one? The set in which we are drawing the horizontal lines. That is A minus B. Similarly, if we see, then this set is B minus A. B minus A, which is having the vertical line. This is B minus A. So let us first understand what is the meaning of A minus B and B minus C. As you are seeing A minus B, this set is made by deleting A intersection B from A, as this is A intersection. So this is called the difference of sets. Difference of sets. So if you want to take number of elements in A minus B, then it will be given by number of elements in A minus number of elements of A. Complete set AC intersection को exclude कर देंगे, then we will get A minus B. And we can define it like this: X such that X belongs to A, but X does not belong to B. This is the definition of A minus B. What is called? It is called the difference of sets. Similarly, we see one more operation. Although this operation is deleted for this year from the syllabus of maths, as complement. Complement of set. Let A is any set, then A complement is given as X such that X belongs to universal, but X does not belong to, that is universal. And with the help of difference of sets, if we want to write it, then number of elements in A complement is equal to number of elements of universal set minus number of elements. So these are two operations: difference of sets and complement of sets. If we talk about the Venn diagram, then Venn diagram of A minus B is the shaded portion by horizontal lines. And if we talk about the Venn diagram of A complement, then A complement will be the all the portion of this universal set except A. Outside this first circle, the whole portion, the whole region will denote A complement. Okay. So now with the help of this Venn diagram, we are going to establish a relationship between union and intersection. See, let that A and B are two finite sets. From Venn diagram, we have number of elements in A minus B plus number of elements in A intersection B plus number of elements in B minus C. If we are adding all three portions, this is A minus B, A intersection B and B minus C. If we are adding all the three, what we will get? We will get A union B. A union B. So number of elements of A union B will be equal to this. As by the definition of A minus B, we can write it number of element in A minus number of element in A intersection B. From here, plus number of element of A intersection B plus number of element of B minus number of element of A intersection. A intersection B or B intersection A both are same. As we have discussed it earlier also in the properties of intersection, that the intersection of two sets is commutative. So A intersection B or B intersection A both are same. So simplifying it, this is minus A intersection B, this is plus A intersection B, both of these are cancelled out. So number of elements in A union B is given by number of element of A plus number of element of B minus number of element of A. This is very important result for the practical problems on surface. This is the result for two sets. Similarly, if we have three sets, if A, B and C are three finite sets, then we have number of element in A union B union C equal to number of element of A plus number of element in B plus number of element in C minus number of element in A intersection B minus number of element in B intersection C minus number of element in C intersection A plus number of element in A intersection B intersection C. This is the result for three cells. This is the result for two cells. It establishes the relationship between union and intersection. Now, with the help of these operations, we will now find the practical problems and some more results related to it. As we are seeing this result, n of A union B equal to Na plus Nb minus number of element of A intersection. Suppose we have two disjoint sets. Two disjoint sets. What are disjoint sets? Disjoint sets are those sets whose intersection is phi. Whose intersection is phi. They are having no element common. No element is common in it. So let us see what will happen. If I want to make the Venn diagram for two disjoint sets A and B, then I can make it out as that this is set A and this is set B. You are seeing nothing is common in it. Here A and B are disjoint sets. So let A and B are disjoint sets. Then A intersection B is equal to 5. So how many elements will be in A intersection B? If this is 5, then there will be 0 element. 0 element. So if we are going to apply this result for disjoint sets, then we can write number of element in A union B is equal to number of element of A plus number of element of B minus 0. So nothing. So this is the result whenever two sets are disjoint sets. Then their union may be given by number of element in first set plus number of element in second set. Okay. So these are the results. On the basis of these results, now let us see some example which will make it more clear. Which will make it more clear to understand this one. So we have a problem, and the problem is that in a group of 800 people, in a group of 800 people, (550) can speak Hindi. 550 can speak Hindi. 450 can speak English. And how many people can speak both Hindi and English? Hindi and English. We have to find. So let us understand. There are two groups of people. One group is that which speak Hindi, another group speaks English, and there is third group also in which the students speak both Hindi as well as English. We want to find the number of those pupils in third group. So we can understand this problem as, let H denote the set who can speak Hindi. So number of people who can speak Hindi equal to 5. And number of people who can speak English is denoted by NE, and that is 450. What we want to find? To find number of people who can speak Hindi and English. Both means and English, and it will be denoted by intersection. It will be denoted by intersection. So we want to find M of H intersection. We know M of H union E can be written as M of H plus number of element in E minus number of element in their intersection. From here you are seeing that 800 is the total number of pupils. So we can write 800 equals to 550 plus 450 minus number of element in H intersection. So on solving, we can write it number of element in H intersection E equal to 450 plus 550, that is 1000 minus 8. This is, therefore there are 200 pupils in the group. There are 200 pupils in the group who can speak Hindi as well as English. Okay. So this type of practical problems will come to deal with these two formulas. Let us see one more problem. And the problem is that we will check whether the given data is right or wrong. Let us see. Out of 500 car owners investigated, out of 500 car owners investigated, 400 owned car A. 400 owned car A and 200 owned car B. Car B. 50 owned both A and B cars. 50 own both A and B cars. Is this data true? Or correct? Is this data true or correct? We want to check whether the given data is correct or false. So let us see. Number of pupils who own car A is given 200 and number of pupils who own car B is given 200. Sorry, 400 were for A and 200 for B. And 50 pupils were there who were having both. So both is represented by intersection. A intersection B equal to A intersection B equal to 50. So with the help of this result, we know number of element in A union B is equal to number of element of A plus number of element of B minus number of element of A intersection B. So from here 400 plus 200 minus 50. So 600 minus 50, that is 550. Means the union was 550. What does it mean? It means the persons who were having either car A or car B were 550. While the number of pupils on which the data was investigated was only 500. Was only 500. So what does this tell? This tells if we are treating this one as the universal, then universal cannot be less than the union. Universal may become equal to union but cannot less than the union. So union must be the subset of universal. A union B must be the subset of universal. But here we are seeing A union B is greater than the universal. So that's why this data is incorrect. A union B should be subset of 2. But here number of element in A union B is greater than the number of element of B. So this data is Okay. So there are the two things to be understand. First thing, the number of elements in the universal may be equal to their union, but can never be less. It will always be greater. Second thing, whenever we are finding the intersection, then the number of intersection cannot be less than any number of sets. Always number of A or number of B is greater or equal to number of elements of A. These two things you have to keep in your mind. That intersection cannot be greater than any set. It may be equal to that set. When two sets are equal, A and B are two sets, and these sets are equal, then their intersection is also equal. But in the other cases, intersection will always be less than this. Okay? So this was the problem which we were telling about the result. Now let us take one more problem that will tell us about three sets. Three sets. So, very important problems related on three sets. And these problems are in our miscellaneous exercise NCERT group. Chapter 1 miscellaneous exercise. Last two problems are for three sets practical problems. Let us see the problem from there, and I am taking the problem number 15 on page number 27 miscellaneous exercise. Problem number 15, page 27. This is related to three sets. It says, in a survey of 60 pupils, it was found that 25 pupils read newspaper H. I am denoting the number of pupils reading newspaper H by N of H. N of H equals to 20. 25 pupils are there who read the newspaper H, and 26 read newspaper T. Number of pupils who read newspaper T is 26. 26 read newspaper I. Number of elements in I. So here are three sets, H, T and I. Three types of newspaper, H, T and I. 9 read both H and I. H and I, so I will denote it by H intersection I equals to. Then 11 read both H and T. Number of pupils who read H and T is equal to. Then 8 read both T and I. Number of elements in T intersection I equal to 8. And 3 read all the three newspapers. 3 read number of pupils who read all the three newspapers, H intersection T intersection I. Then we want to find the number of pupils who read at least one of the newspapers. At least one of the newspapers means we want to find their union. We want to find their union. So we can directly use the result as I told you, but I am telling you one another method by which we can deal all problems of like this. Okay? So some other things may be asked in such type of problems that cannot be directly dealt by result. So, to understand it better, let us take the help of Venn. This is the Venn diagram for it. This is the group of people who read newspaper H. This is the group who read newspaper T. This is the group who read newspaper H. And this complete is. Let the number of pupils in these sets are A, B, C, D, E, F. We have taken these 7 variables. 7 variables. Now, by seeing it, we will establish some equations with the help of these variables. As you are seeing, number of element in H is 25. Number of element in H is 25. So, how many elements are in H? A, D, E and G. A, D, E and G. So from here I can write this implies A plus D plus E plus G equals to, may I write like this? So plotting from here, n of t is equal to 26. Which are the elements of t? Elements of t are E, F, G. B plus E plus F plus G equals to. Now from here I, then C plus D plus F plus G. Now see the common element of H and I. This is H, this is I. The common element of H and I are D and G. So D plus G equals to. Then H and T, common element of H and T are E and G. So E plus G equals to. T and I, then F plus G equals to. And C, common element to all the 3 sets. Common element to all the 3 sets, that is G. G is the element which is common to all the 3 sets. So G is equal to. Now with the help of it, let us solve. We will start solving from here. And G is equals to 3. So if we put 1, 2, 3, 4, 5, 6 and 7. 7 unknown, 7 equations. So we can find the value of G, E and all of these from 6 and 7. If we take from 6 and 7, then you can see 3 plus F is equal to 8. This implies F is equal to 5. F is equal to 5. If you take 5 and 7, from 5 and 7, 3 plus E is equal to 11. So this implies E is equal to. From 4 and 7, 4 and 7 you can get D is equal to 6. D is equal to 6. So now from equation 1. From equation 1, we will put the values that we have find till now. Then A plus B, value of B is 6, plus E, that is 8, plus G, that is 3, equal to 8. So this implies A is equals to 25 minus 14 and 3 17, that is 2. The value of A is 8. Similarly from equation 2. From equation 2 we can write B plus E. E means 8. F means 5. And G means 3. Equal to 2. This implies B is equal to 26 minus 8 and 5 13, 13 and 3 16, that is 10. Similarly, from equation 3 we have got C plus D means 6, F means 5, and in place of G we will write 3 equal to 26. This implies C is equals to 26 minus 11 and 3 40, that is 12. So we have find out the value of all the unknowns. Now with the help of these we can now easily tell the every question that is asked. In first part, the number of people who read at least one of the newspaper. The number of people who read at least one of the newspaper is given by number of element in H union P union I, and this will equal to A plus B plus C plus D E F plus G. Put their values, we will get 8, 10, 12, 6, 8, 5 plus 1. So this is equal to 18 plus 12, 30, then 44, 44 and 8, 50. So the number of people who read at least one of the newspaper is 50. Okay, and the second problem asked in it, the number of people who read exactly one newspaper. You can see from the Venn diagram, these are the three persons who read exactly one newspaper, A, B and C. So from here we can write number of people who read exactly one newspaper.